All right, explain specifically what's the contradiction between postulate 1 or postulate 2 and picking and doing a calculation in an arbitrary reference frame. I can't hear anything you're saying, by the way, if you're saying something.
Oh, sorry, my mic was muted. Can you hear me now?
You're good. Yep.
Okay. We're going to go over this real quick, and I'm going to lay out the
I've already read
implications
through
of,
this.
of what it means. Well, I'm going to tell you what it means because it seems like you read it, but maybe there's a lack of understanding, and this might be where our disagreement is. Okay. So
Probably is.
examples of this sort, together with unsuccessful attempts to discover any motion of the Earth relatively to the light medium, right? And this is specifically referring to the Michelson-Morley experiment, which I'll pull up real quick, and we can look at the math derivation, because this is going to be a whole train of logic here to walk you through this, right? So Sotero, oops, is it on that one? Okay, Michelson-Morley, 1887.
Just to be clear, which postulate are you saying that working in an arbitrary reference frame violates? Which postulate? Which one?
That they're all equally valid, because what we're going to see is that they're not all equally valid.
Wait. So the first postulate says that the laws of mechanics, or rather all physical laws, are the same in all inertial reference frames. That's the first postulate.
Mhm.
So are you saying that postulate is false? Is that the
Yes.
claim?
Yes, and I'm going to show you
Oh,
why.
okay. So you just think that the first law the first postulate of special relativity is false.
Well, in
Is
conjunction
that the
with
claim? That's the claim, right?
it's twofold, because not only is that postulate false, the second one is also false because of the measurable fringe between the two that are in relative
Okay, that's
motion.
fine, but that wasn't the claim. The claim was that you made a claim that said that making a calculation in an arbitrary inertial reference frame, violates
It
one of the
does.
postulates of special relativity.
It
So
does.
which postulate does it violate?
Well, it would specifically violate the first one, but in conjunction
How?
with that, well, I'm laying out the line of logic now. So we're
Well,
going to
so
take
if you're going to make a claim that the postulates are false, that's a separate conversation that we could have at a later date. But that's not the claim you made. It's not the claim I care about right now.
I'm showing you how they're false, bro.
Well, that wasn't the claim you made. The claim you made was that working in an arbitrary reference frame violates one of the postulates of relativity.
It does, and I'm showing you how, because the
Okay,
reference frames have to be
which
defined.
postulate does it violate?
Buddy, can you stop interrupting me and let me walk through this? It violates that
Oh.
all reference frames are equally valid because you're not able to use an actual reference frame where an observer exists or where there's relative motion between the two observers, right? You have to define some fixed point for the motion between them to be relative to. That's what I'm going to get to. That's why I'm walking you through this.
To be
Because
clear, where in the first postulate does it say that you have to pick a reference frame where there's an observer? Where does it say that?
as he goes through the paper, he defines time.
Don't care what the paper says. I care what the postulates are.
The postulate is about the paper. I mean, the
No,
paper.
the postulates are separate from Einstein. Like, if Einstein hadn't come up with it, somebody else would have.
The postulates are backed up by what's said in the paper, right? So he states these two postulates.
You might disagree with the postulates. You might disagree with the postulates. If you do, that's fine. The claim is not whether or not the postulates are true. The question is whether or not working in an arbitrary reference frame violates one of the postulates.
It does. And if I can't speak longer than 10 to 15 seconds, then we're not going to figure out how it's wrong.
As the postulate is wrong, or there's a contradiction with working in an arbitrary reference frame with one of the postulates.
The postulate is wrong because it requires using a fictitious
That's not the conversation. That's not the conversation we're having.
Buddy, you're having an entirely separate conversation. I'm trying to show you
the claim.
I know. I'm trying to show you how these things do not. No, man. I can't even speak longer than 10 seconds without you letting me lay out my line of logic.
If you're going to make an argument that one of the postulates is false, that's just not a conversation I'm interested in having in the next 25 minutes. We can do that at a later date, but that's not the claim you made.
Buddy, what the fuck are you even talking about?
You made the claim that that working in an arbitrary reference frame violates one of the postulates of special relativity.
Yes, and if I can't continue the conversation to explain how that relates, and you're just going to keep cutting me off, then we're not going to get anywhere. So do you want to listen for, I don't know, maybe a minute or two, or should I just keep answering the same question?
Go ahead. I just hope that you're going to explain where the contradiction is rather than just claiming that one of the postulates is false. But go ahead.
Well, shit, man, you can hope in one hand and wait in the other. Okay, so now we've got our two postulates laid out. We will raise this conjecture to port, and this is what he's talking about, the laws of mechanics being valid in all reference frames. And then the second postulate, which is irreconcilable from the former, so these two are linked together, it is namely that the light is propagated in empty space with a definite velocity at c, which is independent of the state of motion of the emitting body or the receiver. Now, he doesn't say receiver here, but that is the implication moving forward, because that is what otherwise he's not even saying anything new in physics, right? So do you agree to that? Because some people say that it doesn't apply to a moving observer. Do you at least agree to that?
Well, no, I mean, it specifically doesn't involve the receiver at all.
Ooh,
right.
Okay. We'll definitely have to come back to that because
it seems irrelevant, but that's fine.
Well, if it's irrelevant, then this postulate isn't saying anything new about velocity addition for the source emitter. So this is why this is important, because it's defining the equivalence between the two frames, and he's saying that you can't use light to measure the difference between them. That was the whole implication for that. But then we'll read a little bit further here, because this is the key part in the reference frame situation being fictitious or not, right? So these two postulates suffice to attain for a simple, consistent theory of electrodynamics of moving bodies based on Maxwell's equation for stationary bodies. The introduction of a luminiferous ether will prove superfluous, and so much here as the theory developed will not require an absolutely stationary space provided with special properties, nor will it assign velocity vectors to a point in empty space where electromagnetic processes took place. So, do you guys understand that if you were defining a reference frame, it has to be between the relative motion between two things, right? Now, whether or not...
No, don't agree. That's not how we define a reference frame.
In kinematics, you can arbitrarily define reference frames, right? I agree. To give
in any physical calculation, you can use any reference frame.
To give physical meaning to this theory, you have to use the relative motion between the source and the observer. That's what these two postulates
does it say that here?
Apply. Right here.
Where does it say source and observer anywhere here?
The emitting body.
It does say source. You're right, but that's talking about the velocity of c. It's not talking about the reference frame.
So if the receiver isn't included in this, then Michelson-Morley should register 30 kilometers a second.
No.
Yes.
Why?
The sun's moving. We're moving relative to the sun. There should be a velocity component measurable with light there. If we're in an inertial frame,
the velocity of c is independent of the state of motion of the emitting body, meaning that regardless of what the emitting body is doing from anyone's perspective, it will always be measured to be c.
That is the assertion specifically. And if you're
that doesn't contradict Michelson-Morley.
No, it completely contradicts it, because if the speed of light, let's see here, what they're saying for Michelson-Morley would be that the relative motion between the Earth and the Sun, it measures a null result. It measures no timing difference, right? That's the basis. That's one of the biggest key factors of the theory, is that Michelson-Morley measured nothing, right? And and then when you Lorentz transform, right, you would have an observer on the sun, and you would see that an observer on Earth would measure the 30 kilometer fringe difference, right? But when you transform,
so there is a difference. So you would see something different from the sun. Right? You wouldn't see a different coincidence, but there would be a difference in simultaneity. That's true.
Oh, simultaneity. So let's see here. Before we get to relativity of simultaneity, right? If all reference frame, well, we can come back to that. Slightly separate issue, but equally important. But here's the thing, right? So we've established that source and observer, sun and Earth frame, light can't tell the difference between them when you're in that frame, right? So an observer on Earth should measure C as C, which is what Michelson-Morley would show under your paradigm, given the interpretation of a null, right? So what we're laying out here...
A null? Yes, an observer on Earth will measure, if the emitting body is on Earth, an observer on Earth will measure it at C, an observer on the sun will measure it at C.
Yes.
It's complicated a little bit by the fact that space-time is curved, and so you can't really make non-local measurements in the direct way, but approximately it's fine.
Well, for all intents and purposes here, we're using flat, right? This is a special theory.
Well, no, you definitely so once you're invoking an orbit around the sun, you are no longer in the realm of special relativity and special relativity only, right?
Well, see, here's a minor point of contention, right? So when Einstein originally proposed this, now I agree that with the extension of general relativity, you would have to look at it through that way, so you could do it that way. But the way that this was asserted, firstly, was that Earth's orbit is so big that you can treat it as like linear portions, because he goes on to say here about closed polygonal lines that complete a circle, or a continuously curved line, and otherwise a circle. But if you extend that to infinity, essentially, it's basically a straight line and it doesn't deviate much. So he's saying that his equations still apply here. So the explanation given for Michelson-Morley isn't that, we're free falling through a gravitational well or anything like that, or, through curved spacetime. It's more in the lines of the postulates of the special theory, stating that in an inertial frame, you're not going to measure relative motion with light.
So he was right for the wrong reasons here. He asserted that, well, you can just take the limit of circular motion and treat it as a polygon, and therefore you can treat it as inertial. But this was before he had the idea that gravitational orbits are inertial, because they follow along GD6. Anyway,
no, it's a good point.
It's kind of off topic from the original contention, namely that it's still not clear where in either of the postulates you get a contradiction if you also allow for the calculation in arbitrary reference frame.
Right, correct. Okay, let's circle back to the arbitrary reference frame real quick. So here, when Einstein is saying that, where's that? Oops, it's on the first page. My bad. Okay, so the introduction of a luminiferous ether, right? So this would be the light medium itself as like a mechanism for light propagation. And then also this right here, an absolutely stationary space provided with special properties to assign velocity vectors to a point in space where electromagnetic processes took place. This is the mathematical representation of the ether frame for all motion to be relative to use that as the backbone. Now, what I mean by that specifically is when we go back to Michelson-Morley here, we see how they derived the timing difference for the light as it's going perpendicular to the direction of motion here. And this is based off of, essentially, you would have the background medium, you would have the timing difference in which how much the Earth is going to move over the course of time that it takes for light to traverse 11 meters, right? And they derive the fringe pattern off of that. This is so when you see V over C here, this is just the length of the path light of light here. When you see the V over C, this is Earth's orbital velocity over the speed of light. So when you see V over C, this ratio, this is inherent to that etheric framework of mathematics, essentially, not necessarily talking about
why.
Well, because it's using
beta, which is what V over C is, shows up in Lorentz transformations.
I know.
Why? That's not unique to an ether model that shows up in relativity all the time.
Well, we'll go over the gamma factor
I'm not talking about the gamma factor.
I know, but listen, we'll go over the Lorentz transform here in a second, and we'll show the exact same thing. Because remember, Lorentz's theory was also an ether theory, and the mathematical framework that Einstein proposed is actually identical. Now that he just removed the concept of the of it being an actual medium, and also the mathematical framework of it being a preferred frame to invoke, right? So
yeah, okay. So we're still getting off topic.
No.
What does any of this have to do with why you're not allowed to pick an arbitrary reference frame to do a calculation in?
No, we're
according to the postulates.
Yeah, we're dead on topic, because you would be assigning velocity vectors to empty space, to points in empty space.
What velocity vector was assigned to a point in empty space?
So
by picking an arbitrary reference frame, what velocity vector?
So specifically, when we get into the Sagnac effect, linear or circular, you have to do cylindrical coordinate system transformations. You have to or arbitrarily define a midpoint for the linear variant, which is the same thing. Where
you don't have to. It just makes the math easier.
No, well, you say that, but there is actually no derivation without using a transformation that predicts a first order timing difference without using a V over C.
So if you want to work in a non-cylindrical coordinate system, just apply the appropriate diffeomorphism to go from the cylindrical coordinate system to a Cartesian coordinate system, and then all you have to do is do a Lorentz transform, or actually not even a Lorentz transformation, just an affine transformation back to whatever reference point you want. Like, you can do that. It's fine. The diffeomorphism from cylindrical to Cartesian is well explained. It's
Well,
not even. This is something that was known since like the
it's
1600, maybe 1700s.
gotcha. So
You can just do that if you want.
it's not specifically that it is the cylindrical coordinate system, right? You could make it any coordinate system, like you said, but it's arbitrarily defining that midpoint for the motion to be relative to. That
You
is
can
that
move
is the
around
issue.
the origin of your coordinate system however you want.
Ooh.
The origin of your coordinate system isn't important.
So if you're not using
It's
the
arbitrary.
reference, so if you're not using the reference frame of the source and the emitter to define the relative motion between them, then you're using the ether framework, which is what Einstein specifically was saying his theory would function without.
Sorry, which postulate says that? Or is this just something that you think?
It's something that we read right here.
Which postulate is this?
This is in reference to the first postulate.
So where does it say that using an arbitrary center of your coordinate system, that's equivalent to using an ether?
Right here. Insomuch as the theory developed here will not require an absolutely stationary space provided with special properties, nor will it assign a velocity vector to a point in empty space in which electromagnetic processes took place.
Yeah, so to be clear, how is picking an origin of a reference frame requiring an absolutely stationary space?
Because you are not picking the reference frame in which the observer and the source emitter exist in.
That's irrelevant to the question I just asked.
Nope, it's the...
So an absolutely stationary space is not the same as an origin of a coordinate system.
If no observer or emitter exists in that location, then you're using the framework, which he said will be superfluous here, as in relation to the first.
How is that the framework? Like, it's just not. It's just not. It's just an arbitrary coordinate origin. You can put a coordinate origin wherever you want. There's nothing banned about doing that. And namely, neither postulate says anything about the origin of your coordinate system. Neither postulate says that.
Yeah, so if the laws of mechanics are going to hold true for a source and observer in relative motion...
Doesn't say that source and observer. It doesn't say that.
Well,
you're inserting words here.
No, we went over the reference frame of the sun and the earth and how you would have to be on one to measure the other, right? So it is between source and observer.
You could put the origin of your coordinate system in the orbit between Mercury and Venus if you wanted to. It wouldn't matter. It would just make the math a pain.
Well, listen though. We already agreed that if Michelson-Morley, if this theory didn't apply to receiver, then you could measure Earth's velocity relative to the sun.
We did not agree to that.
Well,
you asserted it. I disagreed.
Okay, then you would be saying that Michelson-Morley should measure a 30-kilometer fringe shift pattern.
I also didn't say that.
Well, even though you didn't say it, that is the direct implication if you don't agree with the source and observer not being able to use light to measure relative motion because the speed of light is constant between them.
That doesn't follow.
It's the only way that Michelson-Morley could predict a zero fringe pattern, even though it measured.
The reason why it predicts a zero fringe pattern is because they are Well, so in this case, it absolutely does depend on where the intersection point is in space and how that's in motion relative to the lab frame. And because it's not in motion relative to the lab frame, you're not going to see any particular fringe shift. But that has nothing to do with picking a reference frame. It has absolutely nothing to do with picking some reference frame located at the detector, located at like the eyes of Michelson or the eyes of Morley. Like, it's completely irrelevant. Like, it seemed like that, like, if we're just talking basic Newtonian mechanics, which is the limit of special relativity and the limit where the speed of light goes to infinity. You know that you can just, like, any calculation you do, and we teach this to like engineering undergrads first years, right? any calculation you do, you can pick the origin of your XY coordinate axes to be wherever you want on the sheet of paper, and all of the calculations still work.
Yeah, that's
That's a
not.
familiar idea, right?
Yeah,
Because
that's
that's
not
all we're
my
doing here.
point of contention, though. Right?
That's all we're doing when we pick
this.
when we pick an origin of our coordinate system to be, say, in the middle of the Sagnac interferometer.
Yeah,
That's all we're doing. We're just plopping down an origin in an arbitrary place that's convenient.
I totally get what you're saying, but our boy Einstein there specifically is saying
I don't care what Einstein says. If it doesn't violate a postulate, it doesn't matter to me.
Well, it does. And then, so here's the thing, right? You say that
Okay,
we don't
what's
care
the
what
contradiction?
Einstein's
What's the actual contradiction?
using the frame which no observer exists in violates the first postulate. It shows
where in the first postulate does it say that it has to be where an observer exists? Where in the first postulate does it say that?
If there is no relative motion between them, and you're defining an inertial reference frame as moving at a constant velocity, and the laws of physics are going to hold true there, then you have to.
Where does it say anything about an observer?
That is the implication of it, man. We already.
I think you're just reading the word implicate. You're just reading the word observer into it when it's not there. Like if you ask anybody who's well studied in relativity, they'll say, yeah, like this is not what an observer. This is not what an inertial reference frame is. It has nothing to do with a person or a camera or whatever being there. Like it's completely unrelated.
Well, as we continue to read on through the paper, what he talks about is relative motion between two people. He gives the example of how time is different between two observers, right, as a function of their velocity. So it doesn't. I'm not saying
great way to intuitively understand what's going on.
Yes,
it doesn't mean it's required.
Well, it is, unless you want to contradict this portion.
Does it say observer anywhere in this paragraph? Anywhere?
Yes.
Where?
Via implication.
Okay, so it doesn't. So it doesn't say that word anywhere.
We already went over that at the beginning.
Okay, so you agree that nowhere in either of the postulates does it say anything about an observer being required to be the center of a reference frame. It doesn't say that anywhere in either of the postulates.
Not in those postulates.
As written here.
Not in this, and not in the postulate specifically, but as he continues.
Then it doesn't violate them. It doesn't. Those aren't the postulates.
Here's the posty. Here's the rule for the posty. Right.
That's not a rule. That's just that's an observation.
Nope. This is the backbone of why the postulate is true, right? From his perspective. So he's saying here that the introduction of the light-bearing medium will prove to be superfluous.
This isn't a backbone. Yes. This is like his like philosophical conclusion. This isn't a requirement. This is just him musing about what the postulates, if true, mean.
And if they're true, you can't use an arbitrarily defined reference point where there's no observer for motion to be relative to. That's exactly the purpose of this, bro.
Where does it say that?
Okay, listen. When we apply the Lorentz transformation to Michelson-Morley regarding Earth and the Sun, what are we transforming to and from, right?
Does it say that anywhere in the paragraph or no?
Let's just walk it through logically and how it applies before we get to trying to say that it
we
applies
don't have time to do that because I have to go in like 5 minutes.
Gotcha.
Because I have a scheduled live in like 5 minutes. So does it say anywhere in this paragraph anything about observers being required to be at the center of at the origin point of some inertial reference frame? Does it say that anywhere?
Yes.
What's the sentence?
The direct implication of that is right here in this statement.
Where's the implication about the word about anything about observers?
The luminiferous ether would be the fictitious frame.
Has nothing to do with observers.
Well, I stated the light-bearing medium and the mathematical framework for V over C, where that is the reference point at which the motion is going to be relative to. This is specifically.
You're doing a lot of reading into this.
It's very straightforward. We're looking at the math derivation of how they apply
apparently not, because
no, you're right.
A century of physicists apparently weren't smart enough to understand it.
Fair enough.
Random guy on the internet is.
Well, it's not random guy on the internet. This is just the classical. I mean, this is like to me, it's straightforward, right? Because we're using the V over C relationship. We're deriving the distance changed based off of an etheric framework. This is the other side of the luminiferous ether argument. This ether frame that we're making the motion relative to is defined here specifically. So you see here, there's no transformation between anything. There's no different.
Well, yeah, the Michelson-Morley experiment predated relativity.
Well, I know, but
It's not surprising that they weren't using the notation of relativity to talk about it, right?
right. But I'm showing you the mathematical implication of it, because that's kind of been lost in modern times with the V over
The
C.
mathematical implication of relativity is like wildly well understood.
I'm saying the classical and the ether framework for the math. That's what I'm saying.
Well, I mean that's great, but that wasn't the like if you want to say that the postulates are wrong, that's one thing. But I think you're not think. I know for a fact that you're misunderstanding the postulates because you're claiming that they say something they don't say.
Well, I'm showing you specifically to what Einstein was referring to when he was saying that and how it applied, so that when we look back at Lorentz transformations, we see that they're between source and observer. And then, unless you need to invoke...
No, they're between inertial reference frame and inertial reference frame. That's what a Lorentz transformation is.
Yes, defined by a location where there's
a
source.
Inertial reference frames are arbitrary. They have nothing to do with observers or sources.
They're defined by being in relative motion to one another at a constant velocity.
They are defined by a set of coordinates and a velocity vector, or they're defined by an origin and a velocity vector. That's how they're defined. They're defined by a point in space and a direction and magnitude. That's what defines an inertial reference frame.
So long as the motion between the two actually exist.
There's no two. There's one.
Then I would agree with you. The sun,
like an inertial reference frame is just a point and a velocity.
The sun and the earth.
The sun and the earth, yeah. So if assuming the earth isn't rotating, then yeah, it's in an inertial reference frame. Although it's not in a, you can't transform between the earth's reference frame and the sun's reference frame because this is not flat spacetime.
Well, this is explicitly what was put forward to answer Michelson-Morley in a way that
he didn't understand gravity at the time, but that's fine.
Well, even
he was right for the wrong reason.
Well, even understanding gravity, what we went over earlier, where that guy was using the space-time metric and taking derivatives of it to define a coordinate system that he could set up for cylindrical, he had to do the exact same thing. So it doesn't matter what theory you're in or not, because actually Paul Langevin in 1917 came up with the cylindrical transformation for general relativity to try and answer the Sagnac effect. So Einstein actually never came up with an answer for it. So you're saying that
Einstein's not like the king of relativity.
Well,
he was a brilliant scientist, and then he died, and relativity kept going, right?
It is a specific framework laid out with rules on how it works and
there
why it was derived. And if you contradict
there's two postulates. Those are the only two postulates that we require.
I agree.
You can muse on about the philosophical implications of those if you want, but either those two postulates are experimentally true or they are not. Now, it seems to be the case that they are experimentally true, and nothing about doing a calculation in an arbitrary reference frame violates either of the two postulates. Now, if you want to say, well, these two postulates mean that there has to be an observer at the origin of your reference frame, you can assert that if you want, but it has nothing to do with special relativity.
Okay.
But I got to run. We can continue this at a later time, but I have a live schedule now.
Absolutely, man. I appreciate the back and forth.
All right, later.
Later.